we'll see whether we can solve it or not. Okay. So can you solve this problem, students? Solve or find. First question. Find limit x tending to 1, x square minus 1 divided by magnitude of x minus 1. Can you find what is it, students? Dash. First question. Second question, I'll put one by one. People who are doing it fast can go to the next problem again. So speed is important. So you have to get the speed. Okay. X is equal to x tending to 0, cube root of 1 plus x minus cube root of 1 minus x divided by x. I have promised that there will be practice even when you sit in the class only. Okay. There is no requirement of doing practice otherwise. Okay. You sit in the class, practice happens. Okay. Third one is this. Limit x tending to, sorry, n tending to infinity, n tending to infinity, n into 1 cube plus 2 cube plus 3 cube plus so on up till plus n cube, the whole square divided by 1 square plus 2 square plus 3 square so on plus n square, the whole cube. You can refer to internet if you want. Okay, is equal to dash. Third one. Fourth one, limit n tending to, say, infinity. Limit n tending to infinity. These kind of questions have appeared in GATE, students, so we have to solve this. Okay, n tending to infinity. Okay, just a second, students. Let me see it. Limit n tending to infinity. Let us have it as the first one. Did you get, students? N tending to infinity. We have 1 by 1 into 3. It's not 1.3, 1 into 3. Okay, plus 1 by 3 into 5 plus 1 by 5 into 7 plus so on up till 1 by 2n minus 1, 2n plus 1 is equal to dash. The first one answer, students, does not exist. See whether you can see. Not just because x minus 1 modulus is there. Do it and tell me what is the right hand limit, what is the left hand limit here.
Minus 1 and 1.
Minus
1 and 1. Sorry, minus
no,
2
wrong.
and 2. Minus 2 and 2.
I got 2 and minus 2.
2 and 2, right? So right hand limit, if you say right hand limit is 2, left hand limit is minus 2, correct? So it does not exist is correct, but right hand limit and left hand limit has to be done. Second one, I hope everybody got this. Speed is the key now. For these, you can refer to internet now, but later on you have to keep in mind. Okay, let me tell you, sigma n. If you say sigma n is equal to, for this, I'm giving you the formula. This has to be remembered. Okay, n into n plus 1 divided by 2. If you take sigma n square, that is equal to n into n plus 1 into n plus 2n plus 1 divided by 6, and sigma n cube is equal to n square into n plus 1 square divided by 4. These formulas has to be remembered, students. Write it in your formula sheets. Okay, infinite series, okay, or big series, okay, summation of series, okay, that you can use to find the answer for that. These three equations you use, okay, these three formulas you use to get the answers here. Okay, yeah, second one, what is the answer, students? If you have not got it, I will tell you. First one, students who did not get it, limits. Practice should be done in the class itself. Okay, so since we are having full day classes, okay, so you don't have any other time, I know that. Okay, afternoon you can take some rest and review, no other things. Okay, get disconnected from every other things. Okay, maybe 1 hour of this one, what you say, 1 hour of 1 hour of sleep and 1 hour of play should be done. Body exercises should be done. Okay, very important. If body exercises are not there, mind will go weak. Keep in mind, don't sit at a place for long. Half an hour you can walk here and there between one class and other class. You can walk, because 8 hours when you're sitting at a place, there might be a problem. Physically your body may have some problem. Do some home work at home, help your mother. Okay, I'm saying even boys, okay, not just girls. Do some cleaning, something. Cleaning, you know, students, is a great exercise for mind. You clean your room, okay, that itself is a great exercise for your mind. Sitting at a place, you will make your mind blunt. Okay,
Sir, is second one 0?
second one is not 0. Second one is 2 by 3. I may be wrong, but I've done that calculation. Okay, let us see that. Check it out. 2 by 3 is what I got. Nitin, what did you get? Second one. Nitin ji,
I'm getting 0 again.
you're also getting 0. Then maybe I am wrong. Let us check it out.
Both
Let
are
us-
cube roots, no, sir.
Sir, 2 by 3, 2 by 3.
Both are cube root. Yes, both are cube root. Let us check this out. Okay, this is question mark. Others check it out. Others check it out.
Oh, wait, sir, wait. I think it's 2 by 3. Yeah, correct.
2 by 3 is correct.
Yes.
Yes, sir.
Because minus has not been taken into consideration probably. 1 plus x, 1 minus x. Third one. Other students who did not get the first one? Anyone who did not get the first one till now?
Excuse me, sir.
Yes.
Sir, in the first one, when we go from left-hand limit, we'll go limit of extends to 1 minus, right, sir?
1, yeah. So what we get is here. So we have to go as f of x is equal to, when you go with our previous one, you can get this as x square minus 1 can be x minus 1, sorry, magnitude of x, magnitude of x minus 1. Okay, when you say it is equal to x minus 1 when x is greater than 1, greater than or equal to 1, correct?
Yes.
Now, when it is equal to minus of x minus 1, when it is x is less than 1, make sense?
Yes.
This is magnitude of x minus 1. This you have to apply.
Yes.
Do that and get the answer. This comes with a right hand limit. This comes with left hand limit. Do it, students. Third one, Nitin got the answer? You have to work on speed now, okay? Accuracy and speed is what you have to do. And for that, you have to do practice. And practice happens in the class itself. Jivaraj got the answer for the third one?
Sir, getting.
Is it? It is 27 by 16. Whatever the number is. You got 27 by 16?
Yes.
Very good. Fourth one. Now you have to work on accuracy, students. Okay, concept is done. So first is concept. First step is concept.
So one.
Huh?
One.
Fourth one?
One.
No, wrong. It's 1 by 2. That's what we get. See whether you get 1 by 2. I may be wrong because I have solved it by myself. Okay, I may be wrong. Okay, so check it out. Okay, so first one is concept, second is accuracy, third is speed, in that order itself. Okay, do not take speed as the second one, third as accuracy. No, first accuracy, then speed. First concept, second accuracy, third speed. Okay. How many of you have not done the first problem yet? Raise your hands. Raise your hands. Okay, let me give a poll. I'll try some other things. Okay, polls. Shane Sequeira. Okay, good. Shane Sequeira did not. Aditya. Okay, very good. Okay, let me check a poll. Okay. Okay, that takes a long time. Don't worry. How many of you have not done the second one till now? Lower your hand, Aditya and others. Okay. Yeah. Yes. Second one you did not do. Siddhi Vinayaka. Okay, good. Others didn't. How many of yeah, Sagar Bangera is in the second one. Do it. Okay. Okay, good. Who has done all the four? Who has done all the four? No one. Nitin, where is Nitin? Nitin has not done the fourth one. Okay. Okay, fine. Third one, others. Fine. So first one, whoever has not done, do it first. Now, when you're not able to do, go back to your previous 3 years one. You go back to the notes and do it. Now it is
Fourth one I
open.
got, sir. 1 by 2. I got.
Very good. 1 by 2, fourth one. So Nitin got all the 4. Others. I think it was Nitin, is it not?
Yes, sir.
Good. Others? Practice. This is practice stage. Okay. The first one we will see. Okay. The first one is like this, students. Okay. So first of all, limit x into 1 plus, if you say, that is equal to x minus 1 into x plus 1 divided by x minus 1. Why? Magnitude of x minus 1, or sorry, modulus of x minus 1 is actually equal to x minus 1 for x is greater than or equal to 1, and minus of x minus 1 for x is less than 1. So this is 1 plus is we are coming from the positive direction. So this cancels. X we put it as 1, so you will get it as 2. This is right hand limit. When you consider left hand limit goes as limit x tending to 1 minus x minus 1 divided by x plus 1, and here you have minus of x minus 1, correct, because it's minus of x minus 1. X minus 1 cancel, this minus remains, and what you have is minus 2. So left hand limit is not equal to right hand limit, so limit does not exist. Any doubts here, students? No doubts? Let us go with the second problem. Okay, second problem is like this. Okay, so you have limit x tending to 0, cube root of 1 plus x minus cube root of 1 minus x divided by x. Now this can be written as limit x tending to 0, 1 plus x raised to 1 by 3 minus 1 minus x raised to 1 by 3 divided by x. Correct? So this can be written as limit x tending to 0. Okay, I can write this as, here you see it is not, it is coming in, when you say x tending to 0, you get 0 by 0 limit. You see 1 plus x, you get 1 here minus 1 divided by x, which is 0, correct? So that is 0 by 0. So applying L'Hospital's rule, we can write this as 1 by 3, 1 plus x raised to minus 2 by 3, correct, into we can say minus 1 by 3, 1 is coming here because it's there, 1 minus 3, 1 minus x raised to minus 2 by 3 into minus 1, because there's a minus x here. Okay, divided by here 1. So when you apply x is equal to 0 here, you get this whole thing, this is 0. So 1 raised to something is the same thing, so it is 1 by 3 plus 1 by 3, that is equal to 2 by 3. Easy, students? Easy. Correct. Direct. If you can do it, it's easy problems. These are all easy problems. GATE gives only easy problems. It doesn't give tough problems. And these easy problems you have to crack. Okay. So now, first of all, what is given here? Third problem is this. Limit extending to infinity. We have n into 1 square plus 2 square plus 3 square plus so on up till n cube square divided by, we have 1 square, sorry, this is 1 cube, I'm sorry, 1 cube plus 2 cube plus 3 cube up till n cube, 1 square plus 2 square plus 3 square plus up till plus n square, the whole cube. What is the answer has been asked. Okay, this can be written as just as I've given it. Okay, so this is equal to limit x tending to infinity. We have, sorry, n tending to infinity, I'm very sorry, it's not x, n tending to infinity. Here also n tending to infinity. We have n, and then we have n square into n plus 1 the whole square divided by 4 and then the whole square. Okay, because cube, this is the rule, is it not? We have done it here. Observe, I have given this. This has to be remembered. Okay, if you don't remember this, you cannot solve this. Okay, so those things has to go on your this formula sheets. Okay, and here we have n plus n into n plus 1 into 2n plus 1. Okay, 2n plus 1 divided by 6 the whole cube. Okay, now you can solve it. Okay, when you solve it, you get limit n tending to infinity. We have this as, when you make a this, you get n power 5, okay, into n plus 1 or 4 divided by, here we have this 4 square 16. Excuse me, students. 4 square is 16, and then we have here on the other side n cube into n plus 1 cube, correct? N plus 1 cube, n plus 1 cube, okay, and 2n plus 1 the whole cube, correct? And 6 cube is 216, goes to the top left. Okay, when you solve this, you can cut when n tends to infinity is there, is it not? So when n tends to infinity, we'll cut this. So this comes as n power 4 limit n tending to infinity. Here we get n cube, so n square into n plus 1 cube is there, that is just that, okay. And then here 216, correct? 216 divided by, let us have this as 16 into n plus 1 cube is cancelled, so we have 2n plus 1 the whole cube, correct? 2n plus 1 the whole cube, that is what you will get, correct? Now when n tend to infinity, what we can do, we can open this up actually, okay. So when we do that, what we get here is only when you consider 2n to the 2n plus 1 the whole cube. How can we open this up, students? N cube is not there, so that is cancelled. N square comes, okay.
We can take n commons,
From
both.
both.
Numerator n common and denominator n cube common.
How do you take n cube common from this?
Sir, we can apply directly that rule of polynomial now here.
Yeah, binomial theorem we can apply. Okay.
Yeah, directly, because major degree will be 3. No?
Major degree will be 3. Okay, yeah, the rule of polynomial we can put here. Okay, so we get here, this is cube, you know. So maximum is polynomials only. That maximum polynomial is, see the denominator, yes, very much. Okay, so what happens here, see, we can apply this rule, observe. Okay, so degree of numerator is less than degree of denominator, then it is 0. Now here what is happening, degree of denominator is greater than degree of numerator. Then what happens, you have to take only the what do you say, it will go with the, sorry, I'm sorry, degree is the same, I'm sorry, degree is the same. It comes to third category because degree will remain the same, observe here. So here in this case, degree will remain the same, observe. So what happens, this becomes limit n tending to infinity. So degree is n cube here, and the what do you say, and the coefficient is 216 for this, because n cube and this one, okay. For this particular thing, the degree would be 16, okay. This n cube, when you open it up, what you get 2 n cube, is it not? So what we can get here, 216, okay, and then here n cube and then something else, okay. And here in this case you will get we can get this as let us 8, right? 2 cube, right? So 8 we will get, 2 cube you will get, is it not? 2 cube into n cube, okay, plus something else, that we are not worried, okay. So n cube can cancel, that particular thing we can use. So we can use this as 216 divided by 16 into 8, and the answer comes as 27 by 16. Makes sense? Anybody who did not understand this? Anyone who did not understand this? Okay, you are taking the biggest what do you say, coefficient, that's it. Okay, kindly raise your hands who did not understand this. Last line, who did not understand, raise your hand. Everybody understood, very good. Okay, next point. Okay, next one we are solving is the third one, that is a fourth one.
Sir, can I please show once the previous slide?
Yes, please. Write this down. This time I'm concentrating on practice, students, a lot of times compared to last time. Okay. Because I feel last time I was busy in my PhD work, I did not concentrate on practice. Now I'll concentrate on practice. Okay. Every day there will be practice problem in the class only. Okay. Because practice only makes perfect. Karat karat abhyasate jadamati hota sujan. Done? Done, Ramakrishna?
Yes, sir. Yes. Thank you.
You have to tell me, otherwise I'll be waiting for the person. If a person says, sir, show me a slide, that means I'm waiting for him to react later on, to change the slide.
Okay. I just completed, sir.
Okay, fine. Okay, then it's fine. Okay. Fine. Then. Fourth one, we have limit n tending to infinity. We have 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 and so on up till plus 1 by 2n minus 1 and 2n plus 1. How do you solve it? Okay. To solve this, what we have to do is we have to get this as, if you consider, we have to, just a second, we get is 1. Okay. So if I consider this, this is nothing but we can say we are, if I consider this is nothing but limit n tending to infinity sigma of, okay, 1 by 2n minus 1, 1 by 2n minus 1 and 2n plus 1, correct? So now when you do this, what you will get is in this fashion when you do, okay, just a second, students.
You have to split it, sir. Like 1 minus 1 by 3 plus 1 by 3 minus 1 by 5 and divide by 2.
1 minus
1 by 3. Get then divide by 2 with all terms.
yes 1 minus 1 by 3, it is 1 by 3, correct? So 1 minus a half into 1, correct, that's how we have done it. Let us see how to do it. Okay, so this one can be written as limit n tending to infinity. Okay, this 1 by 3, if you see 1 by 3 can be written as half into, correct, 1 minus 1 by 3. Okay, and then this would be 3 into 5 would be half into 1 by 3 minus 1 by 5, correct, 1 by 3 minus 1 by 5 plus half into 1 by 5 minus 1 by 7. Okay, like this it moves. This is one of the important ways we have to solve. These questions have come. Okay, so that is how it is. So we can write this as equal to, this can be written as limit. We will do similar more problems, students. Limit half, this has not been introduced to you, so maybe it is difficult. So it is 1 minus, okay, it can be n tending to infinity, half into 1 minus, okay, here we can write this as 1 by 2n plus 1, correct? 2n, sorry, 2n minus 1, correct? 2n minus 1. This is, one second, students. I think I made a mistake there. This is summation, okay? This summation, when you take n times, we are adding it, okay? So why did we get this like this? This comes as partial fractions. Wait a minute. Okay, so we can write this if you get it in this fashion. Okay, if you get it in this fashion, let me do it again, students. Okay, let me rub this off. Let me write it again. Not just you have to remove it. Okay, just we'll write it again. Okay, just in another way I will solve. Okay, so not that it is wrong, it is not wrong, whatever is written, don't have to erase what you have written if you have written. Okay, but if you have not written, you don't have to worry. Okay, this one can be split into limit n tending to infinity. I can say sigma of, if I do the partial fractions, okay, if I convert it into partial fractions, this will be half into 2n minus 1 minus, okay, half into 2n plus 1. How did I get it? Using partial fractions. Using partial fractions. You know how to use partial fractions, is it not, students? Okay, so using partial fractions I got this. And this one in this fashion, if I have, what I can do is I can have this as I can take limit n tending to infinity. Here I can take sigma of okay, limit n tending to infinity, half divided by 2n minus 1, and this half can go out, 1 minus limit n tending to infinity 1 by 2n plus 1, correct? And 1 by 2n minus 1 infinity, when you take it, no, it will become 0, correct? 2n minus 1. And this summation, okay, I'm sorry, this summation 2n minus 1 summation, let us take it. When you summate this 1 by something, Nitinji, how did you get this summation value?
I have the splitting method, sir, the previous one. So in that you will get directly, sir, actually.
What is the basis of splitting? Correct.
No, sir, like split the 1 by 1 into 3 as 1 minus 1 by 3. So all the rest of the terms will get cancelled. 1
by 3 gets cancelled. I'm sorry, I made a big mistake here. Okay. Yes. This is one way. I was trying this one. I'm sorry, I got stuck, students. My practice is not there. Riyaz, when it is not there, it misses out. Okay. So yes. So this is because of the lack of Riyaz. Okay. So the way we have to do is limit n tending to infinity. What you have is half into, we have this one can be written as 1 by 1 minus 1 by 3, right? Okay, plus we have 1 by 3 minus 1 by 5, correct? You will get this one only, 1 by 3 into 5, correct? Plus we have 1 by 5 minus 1 by 7, okay, plus so on. Now observe here, minus 1 by 3 and plus 1 by 3 cancels. Minus 1 by 5 plus 1 by 5 cancels. Okay, like that when you go at the end, what remains here? Plus 1 by 2n minus 1, 2n minus 1, minus 1 by 2n plus 1. This remains, correct? When we go in this fashion, this remains, correct? So when this remains, this will cut with the other one. So what remains is minus 1 by 2n plus 1, correct? So the whole thing will come as, this will be equal to limit n tending to infinity half into 1 minus 1 by 2n plus 1. And when n tends to infinity, this goes off to 0. So it is half. We have to substitute here 1 plus 1 by infinity, correct? And that is equal to 0. So this is half. Make sense, students? Easy. The main reason I was not doing this because miss Riyaz. Okay. So when you miss Riyaz, huh?
Sir, in that series only 1 by 1 would remain, no? Because
that remains
like only 1 by 1 would remain, no? Because even 1 by 2.
No, 1 by 2, last one will remain, is it not? It doesn't have anything to cut.
So the next term.
Next term is not there. It's till n tending to infinity.
Sir, I mean like this 2n minus 1, that is like just for the reference of nth term, no? Like it's still going on, it seems.
See here, what happens, you know? See, 1 by 5 is here, 1 by 5 is here, is it not? So what would be here? 1 by 2n minus 1, correct? And something over here, correct? And that will cancel, correct? Minus here, I'm sorry, minus.
Yeah. Sir, but like 1 by 2n plus 1 is still a term, no?
Yes, it is there. I've taken it here.
Till infinity. Like
Till
it's still a term.
Yeah, the last term. And that term, when you substitute n is equal to infinity, that term goes to 0. Make sense, Divyaraj?
Yes, yeah.
Sorry. Yeah. So let us do some more problems on limits, okay? Until we get skill sets, okay? It's practice.
I have one doubt regarding the previous question, sir.
This question or the previous to this?
Fourth question, sir.
Third question?
Fourth question, sir. Fourth question.
Yeah, please.
Sir, in the second step, you have written limit of n tends to infinity sigma 1 by 2n minus 1 into 2n plus 1, right? So if we multiply it, we'll get 4n square minus 1 in the denominator.
Okay.
So if we write 1 into n to the power of 0, that like can we do using one of the shortcuts you used previously? Numerator is less than denominator.
Let us check. Okay. So you say, huh?
By doing that, like I tried, we get 0.
Yes, sir, we get 0.
Why do we get 0? Because you have taken only this term. You have not taken the addition of the terms.
Yes.
The second step where you have written that summation is like, is it the summation?
Yes,
Because
it is summation. It is
that
summation.
is the last 1 by 2n minus 1. That is the last term, right? So
yeah, 1 by 2n plus 1 is the last term. Yes.
So like previously for the n square series, no, n square and n cube, we had different summation terms, no. So here the last term itself is the summation. So like I'm a little doubtful.
It is not the summation. It is not. Let me put it again. Okay. See now this, if you go with partial fractions also, okay, through partial fractions also, what you will get here is, you will get this as half into 1 by 2n minus 1 minus 1 by 2n plus 1 if you do the partial fractions. Okay, so n depends, it is sigma of this. Makes sense? Makes sense? Hello?
Yes, sir. Like that is the summation of the series, no? That series.
Correct. So when you say summation, first what you have to do, you have to put n is equal to 1, correct?
Yeah.
So we'll put n is equal to 1. 2 times 1 minus 1 is 1. 2 times 1 minus 1 is 1. 2 times 1 plus 1 is 3.
Okay, fine.
Plus 2 times 2 minus 1 is 3. 2 times 2 plus 1 is 5.
Okay, sir. Fine.
So now what is happening? 1 by 3 and 1 by 3 gets cancelled.
Yes, sir.
Making sense?
Like I was doubtful that is it the summation, because for last series, for n square series, we had different summation terms, so that's why.
Correct. That is when it is direct. Here it's not direct. You see? There it was 1 square plus 2 square plus 3 square. For the direct formulas exist. For this doesn't exist. Make sense? Diviraj, clear?
Yes, sir. Got it.
Now let us do another one. Okay? Let us do another set of problems. Okay? Another set. Let's say 1. Okay? Limit x tend to pi by 2 1 minus sine cube x divided by cos square x What is the answer? Let us see.
Go
Second
to
one.
previous slide.
Yes. Let me write this down 1 second. Okay, it's okay. You do it. Okay, first one, please, people, please write, solve this. Okay. Let me write it down 1 second. The people who have done it, Diviraj, I'll go back again. I'll write these equations and then I will go back. Okay. Limit x tending to 0, sine x divided by x, and where is equal to dash. Okay. Where x is in degrees, not in, x is not in radians, it is in degrees. Okay, sine x by x is equal to what? Sine x by x extending to 0, sine x by x is equal to 1 only when it is in radians. Now if x is in degrees, then what is the answer? Third one goes as limit x tending to infinity. What is 1 plus 1 by x raised to x plus 1 plus 1 by x raised to minus x is what? Dash. Fourth one is limit. Fourth one is limit extending to 0, 1 plus 2x raised to 1 by 3x is equal to e power is equal to dash. Okay, it comes as e power 2 by 3. That's a different case. Okay, what is the answers? Okay, you can do it. Okay, Diviraj, once you finish writing this, then I'll go back. Okay,
Done, sir. No need.
no need. Okay, you have written it down. Fine. Now start solving it, students. Let us see what you will get the answers as. So like this, practice has to be done. As many practice you do, more better it is.
There is first one 3 by 2.
What is it?
3 by 2.
3 by 2. 1 second. 1 second. Let me see. Uh,
Yes, sir, 3 by 2.
yes, it is 3 by 2. First one is 3 by 2. Correct. Very good. Super. In India, if you can convince your parents, no, you have done half the things. If your parents are so, in the sense, controlling, you cannot go for that. Anyhow. Not all. People who love their children like anything are the most extreme love. Okay, it's very dangerous. Possessive love is very dangerous. I'm sorry. I'll open this up. Okay, I was into some other things. Three into what is it, Sharan? 3e square by 2. No. Which one you are saying? Second one. E power 0 by 2. Correct. E power 0. That's what you're saying.
Third one, sir.
Third equation. Third one. Okay. Second one, what did you get? Sharanji?
Second one, I didn't try, sir. I went to third one and fourth one. Fourth one, I got e to the power 3 by 2.
Second one is 1, sir.
Yeah. So third one, what did you get?
E square by 2.
E? No, wrong.
E square.
What I got is e power e plus e power minus 1. So that you can
E
say.
plus, yeah. E square plus 1 by e. Correct.
So you get e square plus 1. Correct. That's correct.
Fourth one is e to the power 3 by 2.
The fourth one is e to the power 3 by 2. Let us see. Yes, correct. E power to the power 3 by 2. 2 by 3. Not 3 by 2. 2 by 3.
2 by 3. Sorry.
Correct. So don't make those small mistakes. Okay. Very important.
Second one, pi by 180.
Pi by 180. Very good. Simple. So the students who did not get it, okay, you have to struggle. Okay, you have to take time today afternoon. You have to take time.
Sir, in the third one, sir, if x is equal to 0 only, then we can apply the rule, no, sir. Here it is infinity.
Let us see that. Where is it? X raised to 1 by x. It can be done over even for infinity. Okay. This can be done even for infinity. Let us write the rule again. Okay. Let us see what are the rules we have missed and let us write the rules again. Okay. I think we have missed some rules. Okay. So whatever is the rule for this one can be put for infinity also, I suppose. I've not missed it, but that you can write it like that also. Okay, this can be written only also for infinity also. Okay, limit extending to infinity 1 plus x raised to 1 by x is also e. Okay, similar way this one also can be with for infinity also. Okay, so this one I'll confirm and I'll tell you students. Okay, even the other one, where is it? 1 by x. Yeah. Yes, so it can be 1 by x also. Okay, so it is applicable for infinity also. Okay.
So that question is for first formula. First formula we can apply.
First formula we can apply. No, for the first formula we can apply.
Instead of n, they give x.
Yes. It's the same thing. Correct. I'm sorry. 1 plus 1 by n raised to n is equal to
1 by n. For third one.
Third one extends to 0.
No, sir. Answer of third one. E square plus 1 by e.
You got it as e square plus 1 by e. Fine, no.
Yes, sir. This one, third one.
This is not e square by 1 by e. It's e square plus 1 by e. Not e square plus 1 by e. It is e by plus 1 by e. Not e square plus 1 by e.
No, sir, like if we take e to the denominator, then we'll get that on e square plus 1.
E square plus 1 divided by E. Correct. That's also proper. Anything which is equivalent to this one. In gate, when you come, you will get either this or you will get in terms of dashes. Okay, then you have to say the numerical value. That's it. Done, students? Can we now go with the continuity? Okay. Next, let us go with continuity. So it's very important.
Also.
Hello?
Yes, sir. Second one.
Second one, I'll tell you. It's very simple one. Okay. Second one goes like this. Okay. See, sine of something. What is x? X degrees, is it not? What is x degrees? 1 degree is equal to how many radians? It is pi by 180 radians, is it not, students? Okay, 1 degree is pi radians divided by 180, correct? Into x. So many radians. Now, when you do it, convert into radians here, you can write pi by 180 into x, and here we can say pi by 180, correct? Now, this is in radians. So this will be 1 limit extending to 0. This will be equal to 1. So what is the answer? Pi by 180, is it not? Makes sense? Easy.
Yes, sir, but x is in degrees now.
Huh?
X is in degrees, right?
Correct. So let us convert degrees into radians. Getting the point?
Sir, actually how I did is like I applied as L'Hospital rule and I got answer 1. So is that 1 radian?
Pi by 180 is 1 radians, is it not? Correct. No, 1 degrees is pi by 1. Okay, wait a minute. Okay, I am very bad in this. Okay, so 1 radian is how many degrees, students? 180 by pi radians, is it not? Pi degrees, is it not? 1 radian is 1, yeah. So it is, you can say pi by 180 radians. It is 1 degree, correct? So pi by 180 radians, that is. Fine. So what is this? This is 1 degree. The answer comes in radians only, which is 1 by 180, pi by 180 radians. Correct. Instead of having 1 radian as the answer, you have pi by 180 as the answer. Because when you consider radian is just a number, is it not? Diviraj, are you getting that point? What is a radian?
Yes,
What is a radian?
Pi by 180, no degree.
No, what is radian? Define 1 radian.
It's radius divided by
Define 1 radian. Anybody? Nitin? Nitinji, define 1 radian.
circumference by total degree.
Huh?
Circumference by total degree.
No. Anybody else?
2 pi by 360.
No. Definition.
Angle subtended by angle subtended by angle subtended by arc, which is equal, whose length is equal to its own radius.
Very good. That is 1 radian. Correct. So this is the basics which you have to understand. What is 1 radian? It is angle subtended by an arc whose arc length is equal to the radius. That angle which is equal to radius is equal to the arc length. That angle is 1 radian. Very important. So radian, 1 radian. These are basic, students. Okay, angle subtended by the arc. Subtended by the arc of 1 radius. Arc whose arc length is 1 radius. Simple. Okay, so the total, when you consider here, what is the arc length of a circle? Arc length of a circle is 2 pi r, is it not, students? When you consider arc length of a circle, What is the arc length of a circle? It is 2 pi r, correct? When you go for circle, 2 pi r is the arc length of a circle. So arc length of a circle is equal to 2 pi r. So what is the angle subtended? The angle subtended is 2 pi radians. The angle subtended by a full circle on its center is 2 pi radians. Now what is 2 pi radians? 2 pi radians is equal to 360 degree. So we get pi radians, or we can get 1 radian is equal to 360 degree by 2 pi. So that comes to around 57 degrees something. You can check it out. Basics, students, don't forget the basics. 1 second. Done, students? I hope you get the things proper. Basics. How many of you did not know this? Let me see the one. How many of you knew this now? Vishal Shetty. Others? Good. This is the basics. A lot of times we do not know this basics. Okay. Yes, very good. So that is, yeah, good. Super. Remove your hands. Okay. So,
sir,
so very important. These. Yeah. Any doubts here?
Go back to that second problem, sir. The same one. So here, like we are, you have given x in degrees, right? So we are converting into radians. You have now in the question they have mentioned x is in degrees. No.
Correct.
We are converting into radians. So in to x we are multiplying pi by 180.
Correct.
Denominator.
Correct.
Then, generally, like when we try to get that limit extending to 0 sin x by x form, usually we multiply and divide numerator by some numerical value, right? I mean, generally what we do. Here we are converting. So here we are not multiplying and dividing, right? So if we'll get sin x pi by 180 divided by pi by 180 by x, that whole thing will become 1, no, sir? This whole thing will become 1. Yeah, so answer will be 1, no, sir? And 180 we have to multiply, is it not? Again, you have to multiply 180. Why? I'll tell you. What's it? Let me do it again. Okay, to again convert answer into. See, I'll tell you. Limit x tending to 0, sine of x divided by x. This is what is asked, where x is in degrees. X is in degrees. X is in degrees. Now, what is defined is when limit x tending to 0, sine x divided by x is equal to 1 only when x is in radians. Always keep in mind, everything whenever we say an angle, it is in radians. Now, this one has to be converted into radians. Fine. What is x degrees? How do you convert into radians? You convert into radians by putting limit x tending to 0, sine of, okay, what is x over here, sine x over here. You convert this x radians only here, not here, not this. Okay. So when you do this, what is happening? This becomes pi by 180, okay, into x. Now x is in degrees, correct? But now here, if I have changed the sign, correct? See, here I am true, okay. But x, when you say here, when you say x here, if I directly write it as pi by 180 into x, this is what you're saying, is it not? Yes, sir. Okay. Now, when you say, okay. Wait. This gives a trouble. Good question. So here you are saying, sir, we are converting into degrees anyhow. Okay. So we are converting degrees into radians. Fine. So if we convert degrees into radians, I have to convert this also. I have to convert this also. Correct. So the answer should be actually 1. Correct. Yes, sir. But what is 1? 1 is in degrees, correct?
Degree. Okay. Again, that we are trying to convert to radians.
Exactly.
Answer.
Yes.
Okay.
So 1 is in degrees. Let me put it properly. No. That is not the way. Okay. That is
multiplying. We are just converting.
See, let us understand this. Okay. Degree is not a SI unit. Why? See, if you consider radians when you consider, so here in this case you get this as pi by 180 radians. Very important. Okay. No. 1 second.
Sir, actually that we don't know, no, like that 1 is in degree or radians. Like just the answer is 1, right? For that formula.
Yes, for this formula, answer is 1. Correct.
Yeah. So it is not that it is degree or radians, right? It is just 1, right? Value 1.
No. It has to be in radians. This has to be in radians always. This is a number. Yes, I got the point now. Okay. This is just a number. Okay. This X is a number. Okay. So if you're converting this number, I'll come back to this, students. Okay. I will think about it and I'll come back to this. Okay. There is a mistake here. I'll come back here. Okay. I'm getting confused. Okay. So there has to be a cool mind and I have to think about this. Anybody can help me out in this?
Sir, like how I solved is like it is given, right? Like X is in degrees. I applied L'Hospital rule. So I got cos by 1. See, it is given sin X by X. So I applied L'Hospital. By L'Hospital rule, I'll get cos X. Okay. Since X is in degrees, if I put cos 0, I'll get 1 answer.
But for L'Hospital's rules to be applied, it should be 0 by 0, and which it is it not?
It is 0 by 0. And X is given, it is in degrees.
So the
yes, sir. Sin 0 is 0. X is 0. 0 by 0 only, right, sir?
Yes. It should be 1, correct? So the answer here, what is given, is wrong. Correct. I'll come back to that and I'll confirm the students. Okay. It may be wrong also here. Okay. Pi by 180 may be wrong. Okay. It may be 1 directly. Okay. Nitin, what do you say?
I think it's pi by 180. I think it's pi by 180.
Pi by 180. Why? We are not able to say why, is it not? We are not able to justify.
For sin X by X to be 1, X should be in radians. That same angle should be there in the denominator.
Yes.
So when we multiply, like when you convert that X to pi by 180 X, denominator should also have that same thing. Only then we can conclude that limit X tends to 0, sin X by X is 1. For that to happen, we should multiply by pi by 180.
Sir, in this case, denominator is a variable, no, sir. It is not an angle. So we have to multiply, sir, pi by 180. So that this sin X and this will be same and we'll get 1 into pi by 180.
Okay. Let us take it like that now. So what happens is, because this is just a number, not an angle. Okay.
Sir, I think we can ask one question.
But then I'll clarify this, students. I'm not convinced yet, but let me clarify it. Okay. So the answer what is given is 1 pi by 180. Okay. That is the answer. Let us take it now on its face value. Later on, I will clarify that maybe by tomorrow. Okay. So I think we will leave it there, students. Okay, today. Okay. You can go with some more limits, or we will start with continuity a bit. Okay, we will start continuity and then we will see. Okay. Let us start with continuity. Okay. Continuity. Okay. Now, when does a function is said to be a continuous function? Simple thing is that it should be continuous. For example, okay. If there is no gap over there. Okay. For example, if you say most of the functions are continuous only. For example, mod x. If you say mod x function, y is equal to mod x function. This goes like this, is it not, student? This is the mod x function. This is the mod x function, correct? So mod x function is continuous, observe. It is continuous, it is touching each other, observe. Another thing, if you consider, say, mod of x, for example, mod of x minus 1 divided by what we considered that time, okay? So this is mod of x minus 1 divided by x minus 1, okay? If I consider this one, okay, this is not continuous, observe that. There is a gap over there, okay? Mod of x minus 1 by x minus 1, you will see it will be minus 1 here, minus 1 here, plus 1 here. It is not continuous at, this is continuous, okay? This is continuous, okay? And this one is discontinuous at x is equal to 0. So let us say y is equal to mod x minus 1 divided by x minus 1, okay? This is discontinuous, so discontinuous at x is equal to 0. Make sense? Okay, so depends on whether it is continuous. What we have the idea of continuity, the same continuity thing is there here, nothing else, okay? So it's continuous or not continuous, connected or not connected, that's it, okay? That is continuous. Now let us see the formal definition of that, okay? Now a function f of x is said to be continuous, at a point x is equal to a if limit extending to a f of x is equal to f of a. Very simple. If extending to f of x, extending to a f of x is equal to f of a. Very simple. And also f of a must exist. Very important. Okay. Another point is f of a must exist. Okay. You cannot have it undefined, undeterminable. Okay. So f limit extending to a f of x is equal to f of a, and f of x must exist. Only then it is continuous. Let us see what is Bosco's definition for this. Okay. Yes, another point in addition to that, limit f of x must exist. Okay, another point is limit extending to a f of x must exist. 3 points are there. Okay, limit extending to a f of x is equal to f of a must exist, limit extending to a f of x must exist. All the 3 conditions has to be satisfied. So this is main important. Make sense, students? Let us see some of the examples. Okay. Tell me when you finished writing, students. Then we will see 3 other types of discontinuity. I'm sorry. Sorry. Okay.
So the function f of x is, what is it? It's not correctly visible. Is the function f of x is
Equal to f of a.
equal. No, so in the sentence you have written, right? The function f of x
F of
is.
a must exist. Must exist.
No, so first sentence, first, a function f of x is
said to be. Is said to be.
Is said to be. Okay.
Is said to be. Okay.
Done, sir.
Done. Very good. Now let us see what are the different types of discontinuity. Okay. First one is called discontinuity of the first kind. The types of discontinuity. Types of discontinuity. It seems difficult, students, but it's very easy, in fact. Okay. No, for me it used to feel difficult. Okay, but now it is okay. First one is okay, jump discontinuity. Jump discontinuity. Jump discontinuity is limit extending to a minus f of x is not equal to limit extending to a plus f of x. Simple. Second one. Okay, it is called discontinuity of the second kind. This is discontinuity or discontinuity of first kind. This kind of jump discontinuity happened with modulus of x minus 1 divided by x minus 1, correct? Second one, okay, discontinuity of second kind. Discontinuity of second kind. Okay. Here what happens is the left hand limit or right hand limit or both does not exist. Either left hand limit or right hand limit. Or both does not exist. If the limit does not exist, D and E, if that comes, then it is not exist. Okay, very important. Third one, okay, discontinuity of the third kind. Which is also called a removable discontinuity. Okay, this is called as limit extending to a minus f of x, okay, is equal to limit extending to a plus f of x, but f of a is not equal to f of x. This is called removable discontinuity or discontinuity of the third kind. Simple one, students, nothing great. Okay, but in my PUC I used to struggle with this like anything. Something, if it is not stuck to you, it is difficult always. Okay, and once you keep in mind that it is difficult, it will continuously be difficult. So we have to be very careful with this. Okay. Okay, students, done. Let us do one problem and let us see. We have time, we can go further.
Wait a minute, sir.
Huh?
Wait a minute, sir. Last line.
Okay, don't worry, don't rush, write neatly, okay? But tell me when it is finished, that's it. This way, in terms of when you go very nicely, a disciplined study for around 4 to 5 months now, there is no way you cannot clear GATE, students. How can you not clear GATE? This has to be understood, okay? And you know how much GATE you have excellence, is it not? Now, another. Yeah, please. Done?
Done, sir.
Very good. Now, let us take one examples. Let us take one by one examples, okay? Examples. In that first one, okay? Let us take f of x is equal to 1 by 1 plus 2 raised to 1 by x at x is equal to 0. Let us check that, okay? Now, limit x tending to 0 minus, if you take f of x, if you take this would be nothing but equal to, I can convert this into, we can say, see, observe the way we are doing, okay? Limit x tending to h, I will say x tending to, or h tending to 0, let me put it like this, h tending to 0, f of 0 minus h. See the way I am playing a gimmick here. Instead of x, we are putting 0 minus x because we are going from minus 0 minus, okay? We are going from the negative direction, correct? So limit h tending to 0, f of 0 minus x, which is equal to limit h tending to 0, 1 by 1 plus 2 raised to minus 1 by h. Make sense? Wherever x is there, I am putting minus h here, okay? Because 0 minus h, correct? So this will come as x h tends to 0. This will come as infinity, minus infinity, correct? So this can be, let us substitute now h. When you substitute h here, 0 here, what you will get? You will get 1 by 1 plus 2 raised to minus 1 by 0. That is 1 by 1 plus 1 by 2 raised to 0, correct? Raised to 0, correct? Or raised to infinity, sorry, okay? Because this is nothing but 2 raised to minus infinity, correct? And that is equal to 1 by, I'll write it here, students. This will come as, this is equal to 1 by 2 raised to minus infinity is 0, right? 1 by 1, so it is 1 plus 0, correct? So that is one side, okay? Now let us take limit x tending to 0 plus f of x. So this can be limit h tending to 0, h tending to 0. I can write f of 0 plus h. I hope you are appreciating why did I say 0 plus h. H tends to 0 means what happens from a number line, this is x is equal to 0. So I'll go with h here. So when h is tending to 0, I'm coming down here. When I'm coming here, okay, this is h. So this is x 0 minus h and this is 0 plus h. Makes sense? So we are coming here, okay. So that is equal to, we have this is equal to limit h tending to 0 1 by 1 plus 2 raised to 1 by h. Makes sense? And this actually is equal to 1 by, if you put 0 there, it will be 1 by 1 plus 2 raised to 1 by 0. That goes to infinity. So it is 1 by infinity, that is equal to 0. So what is this happening? Here f of f limit x tending to 0 minus f of x is not equal to limit x tending to 0 plus f of x. So this is discontinuity of the first kind. Makes sense, students? It is discontinuous, obviously. Correct? Any doubts here?
So, 1 by 0 is infinity means 2 power 1 by 0 should be 2 raised to infinity. No?
2 by 1 raised to 0. Yes, 2 raised to infinity. Correct. So that is 1 plus 2 raised to infinity is infinity. No?
Yes, yes.
2 raised to infinity is infinity. 1 plus 2 raised to infinity is again infinity. So that's why I've written that.
So then 2 raised to minus infinity is 0.
Yes. Why? Because 2 raised to minus infinity, when you say, you go, I'm sorry here, okay. When you go with the 2 raised to minus infinity, 2 raised to minus infinity is equal to 1 by 2 raised to infinity. That is equal to 1 by 0. 1 by 2 raised to infinity is what? Infinity. So 0, right? That we have.
Got it.
Got it?
Yes, yes. Got it.
Very good. So this stops our class, students. Tomorrow we will see, we'll continue with discontinuity. Okay. I'll wait till you write. I'll just stop recording and then I will wait till you write. Okay. I'll just stop recording here. Okay. That's it. Then I'll give you time to write. Don't worry.